Okay, let us take some more questions. For example, if I take mod x plus 1 plus mod x minus 4 equals 5. Okay, so here what I am saying is, if you look at it geometrically, there is a number x. Okay, there is a real number x, distance of which from -1, because you can always write this bracket as x minus of minus 1, right? You can write this mod as this, plus x minus 4 is equal to 5. So what I'm saying here is, there is a real number x, the distance of which from -1 and the distance of which from 4. So sum of distances of the real number x from -1 and 4, okay, is equal to 5. Okay, let me draw this number line for you to visualize this problem. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So there is a number -1, which is this one. Okay, there is another number 4, that is this. Now I am looking for a real number x, the sum of distances of which from -1 and 4 is equal to 5. So don't get confused, let us take this number 2 here. Okay, consider this number. The distance of 2 from 4 is 2 units. Distance of 2 from -1 is 3 units, right? So sum of these distances is what? It is 5 units. So 2 is one of such numbers. Okay. Now if you look at any number between -1 and 4, let us say we look at this number, this distance and this distance is again going to be 5 units, right? Why? Because distance between -1 and 4 itself is 5 units. Now you can divide it into any two distances by taking any point here. Let us say I take this point, then the sum of this plus this is going to be 5 units again. So any number that lies between -1 and 4 will satisfy this equation. Okay, so x can be anything between -1 and 4. Now can it be -1? Look at this. -1 is a number which is at 5 units from 4, and -1 is at a 0 distance from -1. So this modulus will become 0 for this number -1, because it is at a distance of 0 from this, and this mod will become 5. What I mean is, when I put -1 here, this will give me 0, and when I put -1 here, this will give me 5, which is what I want, right? So -1 will also satisfy and 4 will also satisfy, because 4 when I put here will make it 0, but this will become 5, okay, which is what I want. So x can be anything between -1 and 4, and it can be -1 or 4 also. So this is the solution. Any number -1, 4 or any number between these will satisfy this equation. But look at any number beyond 4. For example, if I look at this number, okay, what is the distance of this number from -1? It is obviously greater than 5. Okay, because 4 was at a distance of 5 units. So any number beyond 4 will be at a distance of greater than 5 units. So any number beyond 4 will not satisfy this. Similar is the explanation for any number before -1, because this number will be at a distance of more than 5 units from 4. Okay, and the sum will be even higher, because this distance plus this distance will be even higher than 5. What I mean is, if I write it mathematically, mod x plus 1 plus mod x minus 4 will be equal to 5. I took, let us say, -1 here, 4 here. So any number between these, because this total distance is 5 units, any number between these two, -1 and 4, the sum of distances from this number and this number will be 5. So any number between these will satisfy it. -1 will satisfy it and 4 will satisfy this equation, right? Now if I convert it into an inequation, that is, I want to find the sum of distances which is less than 5 units. That means I am looking for a number, the sum of distances of which from -1 and 4 is less than 5. Okay, so I looked at all these numbers that were between -1 and 4. Their sum of distances from -1 and 4 was 5 units. And when I went beyond 4, the sum became higher than 5. And when I went below -1, the sum was greater than 5. So there is no real number that satisfies this equation. No such x. Okay, because you can visualize it on this number line, that any number between -1 and 4, the sum of distances from -1 and 4 will be 5. Any number beyond 4 or below this -1, the distance will become greater than 5. So there is no solution for this inequation. And let me make another question. When I write it like this, greater than 5. So it will be greater than 5 when I go beyond this 4 or below this -1. Okay, so the solution to this will be -infinity to -1, okay, or 4 to infinity. Okay, so these values of x will satisfy this inequation. I hope you have understood this question very well and the geometrical interpretation of modulus also. Let me take a little more difficult question. X square minus 9 plus x square minus 4 and it is equal to 5. Now if I interpret it geometrically, what I'm saying here is I am looking for x square. I'm looking for a number x square, the sum of distances of which from 9 and from 4 is equal to 5. Now look at these numbers on the number line. If I write this as 4 and this as, let us say, 9, okay, this is a number line. I am not writing, okay, let me write 0 also. Okay, so this is 4, this is 9. What is the distance between 4 and 9? Obviously it is 5 units, okay, which is written on the right hand side. And I am looking for a number x square, the sum of distances of which from 4 and 9 is equal to 5. So any number between 4 and 9 will give me the value of x square. So any number here, okay, can be my x square. So what I mean is x square can be any number between 9 and 4. Okay, but when I am looking for the solution of this equation, I am looking for values of x and not x square. Okay, so how I can find values of x from this equation, from this inequality here? I will separate it into two inequalities, x square greater than equal to 4, right, x square less than equal to 9. And what will be the final result? Final result will be the common of this and this, right, because both these should be satisfied simultaneously. The number should be between 4 and 9. X square should be between 4 and 9. So this should also satisfy, this should also satisfy. So when I say x square is greater than equal to 4, another way of saying it can be x square minus 4 is greater than equal to 4, 0. right? Now if I factorize it, I can write it x minus 2 x plus 2 greater than or equal to 0. Okay, so x can be, so now let me again show you on number line 0 1 2 negative 1 negative 2. If I take any number greater than 2 or any number lesser than negative 2 and put it in place of x, it will satisfy it. You can check it yourself. Let us say if I put 3, 3 plus 2 is 5, 3 minus 2 is 1, so 5 into 1 is 5 and it will satisfy it. But if I put any number between these negative 2 and 2, let us say I place 1.5. So when I place 1.5, this bracket will become negative, so it will not satisfy it, right? And if I put anything beyond 2, this bracket will be positive, this bracket will be positive. But if I place anything lesser than negative 2, then what will happen is this bracket will be negative, this bracket will also be negative, the product of which will again become positive. Okay, or you can watch my quadratic equation lecture, then you can simply by looking at it can deduce that x will be greater than or equal to 2 or x will be lesser than or equal to minus 2. Okay, another way of writing it is x belongs to negative infinity to negative 2. It can be negative 2, but it can never be negative infinity, right? And it can be 2 to infinity. Okay, this is another way of writing the solution for this equation. Now I have solved just one part of it. Second part of this inequality is here. X square is less than equal to 9. Again, what I can do here is, if I take 3 here and negative 3 here, so when I put x equal to 3, it will give me 9. When I put x equal to negative 3, it will again give me 9. If I put anything between negative 3 and 3, it will give me values which are lesser than 9. Okay, so the solution of this will be x belongs to negative 3 comma 3. That means x can be negative 3, x can be 3, or x can be any value between negative 3 and 3. Okay, and if you look at quadratic equation lecture, you can write it like this: x square minus 9 is less than equal to 0. So x minus 3, x plus 3 is less than equal to 0. So the solution will be x is between negative 3 and 3. Okay, and it can very well be negative 3 and 3 also. So this is another question that can be solved geometrically. Okay, now we will look at some points, okay, and solve it without using geometry so that we can understand modulus function in great details.